Work. For work to be done, a force must be a push or a pull, and the object must move over a distance. If both do not occur, then work is not being done. For the sprinter, you have to find work by finding the force. A times m equals x. 12.2 meters per second squared times 94 kilograms equals the force. The force is equal to 1,146.8. For the marathon runner, you have to multiply A times M and get F. .3 meters per second squared times 52 kilograms equals F. F equals 119.6. So, since you know the force, you want to multiply force times distance equals work. Force is 1,146.8 newtons, and the distance is 100 meters. So that is equal to work. Work then is equal to 114,680. For the marathon runner, you have to multiply force times distance, and your force is 119.6 newtons times the distance of 42,164.81 meters. And that is equal to work. Work is equal to 5,042,911.28. For kinetic energy is the energy that is possesses due to its motion. It is defined as the work needed to accelerate a body or given mass for its rest to be stated velocity. For the sprinter, the kinetic energy is measured by half mass times velocity squared. Half 94 kilograms times 12.35 meters per second squared, and that equals a kinetic energy of 7,169.56 joules. For the marathon runner, the equation stays the same, which is half mv squared. So then you would take the mass, so half 52 kilograms times 5.5 ms squared, and kinetic energy is 800.87 joules. For potential energy is the energy possessed by an object because of its objects relative to another object, stresses within itself, its electric charge, or other factors. For the sprinter, the potential energy is mgh. Your mass is 94, and you multiply that times gravity, which is 9.8. The height for the sprinter would be 1.2, so you get a potential energy of 1,105.44 joules. For the marathon runner, mgh is the equation. The mass is 52, the gravity is still 9.8, and the height is 1.2. So the potential energy is 611.52 joules. Out of both of those, the sprinter has the highest potential energy because they're going a shorter distance at a faster rate. For power, the more work done, the more power that you are going to need to get the job done. For the sprinter, you divide the work, which is 114,680 divided by 1.01, and you get a total of 113,544.55. For the marathon runner, you divide the work done, which is 5,042,911.28, and you divide that by 2.01, and you get a power of 2,092,494.30. If you were trying to find out how many 100-watt light bulbs can be powered, for the sprinter is 2, and for the marathon runner is 3.